Welcome to Land Grant Today, and today we'll be talking with Dr. Lambert Kanga, Professor of Entomology within the College of Agriculture and Food Sciences at Florida A&M University. He will be sharing with us exciting research findings on honeybee production, how to prevent their decline, and what are some of the biological control methods that he's discovered that are useful for today's honeybees' survival. Welcome back, and I am Cynthia Lamb with Land Grant Today. And today we have with us our distinguished Dr. Lambert Kanga. He is an entomology professor at the College of Agriculture and Food Sciences here at Florida A&M. And thank you so much, Dr. Kanga, for visiting with us here today. And we are excited because we hear that you are an expert on honeybees. And we have heard recently in the news a lot about the decline of honeybee colonies, and I'm just excited to hear about the research that you have been conducting. But could you share with us some of the issues that honeybees are facing today and why honeybees are so important to not just our country but the world?
Thank you for having me, and thank you for giving me the opportunity to talk about honeybee and some of my research. Actually, as you know, honeybees have great economic importance, not only for honey productions, but more so for crop pollinations. Honeybee pollinate more than 400 agricultural crops.
Wow.
And honeybee, as you know, also is very good for biodiversity by pollinating wild crop.
So they don't just pollinate flowers, but they pollinate crops that we eat.
Yes.
In Florida and across the world.
Yes. About 400 crops that I mentioned before, including almonds, blueberry, apple, cranberry, and so forth and so on. Pollinating a lot of crops.
So if we lose our honeybees, we're not only losing honey, but we could lose almonds and pay more for those at the supermarket, pay more for our apples and all the good food that we love to eat so much.
Yes,
so
yes.
That's interesting to know.
That's very interesting. Like the honeybee industry contribute to the production of honey product, we estimate at $7 million and $14.6 billion worth of dollar of pollination of crop and vegetable. And honey product also are used for alternative food and also for medicine. Like a propolis, for example, have antibiotic property. They also have antiseptic property. The bee breads also have those properties. Royal jelly is used for dietary health supplement.
So there are many uses.
Yes, many uses.
Wow,
the bee wax is used for cosmetics, and the venom of honeybees is used for several human diseases such as arthritis, rheumatism, multiple sclerosis. And the genome of a bee has now been sequenced. Therefore, it can provide information to understanding the human diseases and also the behaviors of human, taking a clue for those bees.
So they play a very important role, not only in American and worldwide agriculture, but also in combating these diseases such as cancer, arthritis, and other diseases that you mentioned that are prevalent throughout the world. So there's a lot at stake with honeybees, and we don't want to lose them. We certainly don't.
Oh, we certainly don't want to lose it. They're also used for cough medicine. Allergies, used for wounds, been used for ancient time to cure a lot of human diseases. So it's very, very important, the total package of the honeybees.
Well, how serious is the decline in the honeybee population at this time?
Oh, very serious. Very, very, very serious.
Okay.
Yes. Because we started out with about 5.9 million in 1947, and now we're down to 2.5 million
Oh my, that's
in about
more than
2030.
half.
Yeah, more than half. So they declined about 40%, more than 40% in less than 60 years. So if you don't have those bees, and there will be no food for the table, no fruit, no vegetable. So they're very, very important.
Very important indeed. And you have been doing research on honeybees and on the decline, trying to prevent the decline of the colonies for some time now here at Florida A&M University. So you're pretty aware of some of the problems that are contributing to the decline. Could you share with us what you believe might be contributing to the decline in honeybees?
Yeah, absolutely. Actually, about three major things, and a combination of different factors, which include diseases caused by arthropod pests, such as varroa mite, but also pesticide, exposure to pesticide, also nutrition, because the bees are losing their forage at this point. So those are some of the key factors that contribute to a decline of honeybees. There's other factors, but those are the main ones.
The main ones are mites. And what do the mites do to the bee?
Well, mite is a small creature. Really, what it does is suck the blood of the bees. So we call it vampire mite. Not only suck the blood of the bees, but it also transmit diseases. Several other diseases that are transmitted. Maybe more than 18 types of viral diseases transmitted by mite. So in 2006, there was a big problem associated with a decline, which was scientists termed the colony collapse disorder, or CCC. So the CCD is mostly caused by a combination of factors. One is the one I just talked about, with varroa mite, with small hive beetle. Pesticide exposure to pesticide will reduce the immune system.
Okay.
And also nutritions, sometimes poor nutritions because of lack of landscape for them to forage.
So they're starving.
Yes, yeah, yes. They don't have, usually they used to have a pasture, and those pastures have been transformed to corn productions, for example, for production of ethanol. Therefore, they don't have enough habitat they can get pollen from.
So it's important to have the right habitat for these natural habitat, natural pastures, as opposed to converting the use of the agricultural land to traditional crops.
Yes.
So you mentioned other contributions toward the collapse of honeybee colonies, such as nutritional and pesticides, and that there were others along those lines, pathogens. And how prevalent are GMOs, genetically modified crops, in the decline of honeybees?
Yeah, GMO is one of the factors, especially in Europe, where it's been used for quite a long time. It's one of the factors that we think that is contribute to the CCD, to a decline for honeybees. Because especially some of the chemicals have been used, neonicotinoid type of chemical, which affect the human system of honeybees. So GMO is one of one. In Europe, it's been banned, so we don't even use, those neonicotinoid things anymore.
So when those substances are implanted or inserted into the seed, the bee will actually ingest that chemical?
Yes, because...
And what does that do to the bee?
Yes, so what happened is that the plants been genetically engineered have a Bt toxin, the toxin for the bacteria, the Bt toxin in it.
Okay.
So they express this toxin for good the plant. Therefore, the pollen, the seed, all those toxins. And when the bee come and feed on those pollen, they take it back to the hive, and therefore they take the poison back to the hive and contaminate the hive.
So although it's good for keeping the crop alive, it's not good for keeping the bee alive.
Yes, it's not good for the bees. Yeah.
I see. Well, that's very good to know. It takes me back to the increase of organic crops and how healthy that is, not just for us on the human side of things and consuming the crops, but also in making sure we have crops in the future. and our bees stay alive to continue to pollinate them.
You're right.
So that's wonderful. We're going to take a quick break, and when we come back, would love to discuss with you some of the solutions that you have seen in your research toward contributing to preventing the decline of honeybees. And we'll be right back.
Stronger, healthier babies. Learn more about healthy babies at marchofdimesbaby.org.
Welcome back to Land Grant Today. I'm Cynthia Lamb, and we have with us Dr. Lambert Kanga from the College of Agriculture and Food Sciences. He's a professor of entomology, and he's a leading research worldwide in the study of honeybees. And Dr. Kanga, thank you so much. You've been informing us, for those who are just joining us, you've been informing us about the importance of honeybees and how they pollinate crops worldwide, and all of our crops in Florida depend on honeybees pollinating them. You've also shared with us the decline of over 40% of honeybees worldwide, which is a dramatic decline. You talked about some of the causes of the rapid decline in honeybees, and it was so interesting to learn the various things that cause it, from vampire mites to pesticide use, GMO crops, all of those things contributing to their decline, and how important it is to keep them alive, because not only do they serve our agricultural needs, but they're also used for medicinal purposes. Mm-hmm. So that was a lot of territory that we covered in the first segment. So getting back to those problems that the honeybees are suffering from and causing their death, what current solutions are you aware of that can be used to help keep our honeybees from dropping off the face of the earth?
Yes, we don't want them to drop. So there's several ways to control the mite, especially this is the most important one, the mite is the most important one. Several ways to control the mite have been investigated. It includes chemical control, biotechnical control, genetic control. We don't have biological control yet, but we have those three.
Okay.
Now, biotechnical control involves the use of natural products, such as smoke, and very mite trap devices. But it doesn't provide, it provides very rigorous success. But breeding for resistance is bit underway and look very promises. Okay. So scientists have gone to Russia and find out the Russia queens is resistant to varroa mite. Therefore, they brought this one back here and breed those queens with our local honeybees, and the progeny become resistant, to varroa mite.
So we create a super bee by breeding a genetically superior bee with our bees here in this country.
Yes, because the queen bees have what we call hygienic behavior. So they clean themselves, they groom themselves. By doing so, they take away, because the mite is on the back of the bees. So they take away, they groom themselves, so we take away the mite. Therefore, this hygienic behavior helps them to resist mites infestations. So they brought it back here, so they breed with our local bees and have a progeny resistant to mite. But over time, this tree that we call this tree drift. Therefore, some of the very infested colonies, progeny from these Russian queens, need application of chemicals to be able to survive.
Oh, okay.
So the other area that we use is the chemical control. So people have been using two hard chemicals, which is freevalinate, the pyrethroid class of chemical, and cumophos, the organophosphate phosphate class of chemical. And these have been successful to control the mite for the last 25 years.
So the chemical is used to destroy the mite, but it doesn't harm the bee? It
doesn't harm the bee, those chemicals. So, but the mite become very smart, so they develop a resistance to those one. Therefore, we no longer can use those chemicals.
It's kind of like antibiotics and how those work, and over time, they don't work.
They don't work over time, so they find mechanism to overcome those pesticides. So we brought another one called Epigar, which is botanic-based type of chemical that we're using. But how we know all those chemicals, most of the time resistant will occur to them.
Mm-hmm. Yes. This is just a matter of time before they're not effective. Yes.
Again, so therefore we need, and all those chemicals, the problem with those chemicals is they leave residue in honey and wax. And therefore they're not even safe for the beekeeper. So what we need is an alternative control strategy, which is cost-effective, safer environment. We provide long-term control.
Absolutely. And so we're thinking in terms of the health of the bee, the health of the beekeeper, and also the health of the environment as well. We don't want to leave residue behind that can infect. It can infect other bees. It could destroy the natural habitat of the bees. It could invite other pests, from what I understand. And then the ultimate consumer, we don't want to ingest those chemicals.
So you want healthy foods.
Yes, yes. We want to keep the bees healthy for a lot more reasons than putting honey in our tea. Now, I know just enough about honey to know that raw honey is better than the one that has additives. And this is a little less scientific, but I've always been curious to know, why is it that raw honey is better than the regular commercialized honey that has additives in it?
Yes, when you add some additive to dilute the property of some of the really good ingredient that you have in raw honey. So raw honey is a total package. You got, like I said, antihistamine property, got anticoagulant property, antioxidant property, antibiotic properties, and so forth, anti-inflammatory properties. So the whole total package. You don't want to dilute this one, adding other ingredient to it.
So it's very healing. It contains a lot of healing properties.
A lot of healing
in
properties.
its raw form.
In its raw form. Yeah, so they use to kind of treat wounds, ulcer, cough medicine, and so forth. So you got all is a total package that you can use. So it's better to keep it raw honey than to add different additive to it.
So we need to keep those bees healthy so that their raw honey is also healthy. And you mentioned about biotechnical. You talked a little bit about the crossbreeding of stronger bees that have resistant properties to the dust mite and the self-cleaning that they do. And then you talked about chemical control versus biological control, and you said we're not doing a lot of biological control right now. Why is that? I know we talk a lot about organics now in the news media. People are eating healthier, so you would think that we would be moving along the lines of more biological control. What do you think is causing the delay in terms of adopting some more biological control methods?
Because the procedure is very difficult to undertake. So that's be one of my area that I'm going to be talking about, using biological control for the mites and also for other pests. Honeybees.
Yes, and you have been working in a lot of different research areas, and from what I understand, your research includes insect toxicology, insect pathology, biological control, insecticide resistance, insect molecular genetics, and insect population dynamics. So you are well researched in all of these areas, and I am excited to hear about some of the insights that you have gained in your research using biological control methods to prevent the honeybees from declining. And so we are going to come back after our break. We will talk about more of the research that is being done to improve the longevity of the honeybee and prevent their demise. So we'll be right back. Stay tuned.
There's a monster in my bathtub.
For a child with asthma, monsters are everywhere.
There's one on the couch. There's a monster on my bed. Please make the monsters go away.
Learn more at noattax.org.
And welcome back. I'm Cynthia Lamb with Land Grant Today, and our guest today is Dr. Lambert Kanga. Thank you, Dr. Kanga. We've been so educated and informed. I've been enlightened on the uses of honeybees, their importance toward crop production in the United States, as well as medicinal purposes. Some of the diseases that they've been battling, causes for their decline, and the vampire mites. There's so much affecting the honeybees. And your research is very important in protecting this important insect that contributes so much to not only the state of Florida's agriculture, but 400 crops worldwide. Am I correct?
Yes, you're correct.
Yes.
Yeah.
Awesome. And you've been telling us a little bit about the solutions that are currently being used in terms of chemical solutions and biotechnical, but the preferred method would be biological control because it's the most environmentally friendly and healthiest to the bees. And that, I understand, is an area of expertise in your research. So won't you kindly share with us some of your findings in that area of biological control?
Okay, yes, I'll be pleased to do so. As I mentioned before, chemical control leave residue in honey and wasp. Therefore, you need to have a biological way to control the mite without, causing so much problem in a beehive. And that's the reason why the Center for Biological Control, which the missions is to promote and generate ecology-based pest solutions to agricultural problems and to also natural resources and public welfare. So this center have worked on developing a biological control way to monitor and manage the varroa mite.
And the center you're referring to is the Center for Biological Control here at Florida A&M?
Florida A&M, in the College of Agriculture and Food Sciences.
Wonderful. And so you're working on various areas. Could you share with us some of your findings in that area of biological control?
Yes, actually when we started, so the challenge with using biological control is that unlike pesticide, it takes about 3 to 10 days for the biological control agents to kill the pest. And most biological control agents that we work on fungus pathogens, of the fungal pathogen have optimal germination between 25 and 32 and may not last long enough in a beehive.
You say 25 to 32 days?
Or no, 25, grow between 25 and 32 degrees Celsius.
Oh, okay.
Yeah.
Okay, the temperature.
The temperature.
Okay.
Yeah. Therefore, they may not survive inside a beehive, which run about 35 degrees C. So that's challenge number one. And challenge number two is that the mite instead live inside the seed broods, in a dark area inside brood. So feeding on the mite. Therefore, when you take it out, it may not survive outside the beehive for long enough for us to use a fungal bioassay. Like I mentioned before, it takes about 3 to 10 days, for the fungal bioassay, the fungal pathogen to kill a host. So therefore, we need to develop, a technique to be able to alleviate those challenges. Fortunately, we're able to develop for the first time a successful rearing and bioassay technique that we use to screen several fungal isolate. We screen like more than 100 fungal isolate and find that 2 of them were highly pathogenic to a mite. That's it, kill the mite, but it doesn't affect the bees.
Oh, that's great.
Yes. So we got in the lab and we said, okay, we know you work in the lab, so we're going to try to see if it's still effective in a beehive situation outside, outside the laboratory.
Yes, it's one thing for it to kill the mite in the lab, but can it survive the conditions of the beehive, the temperature and the environment?
Yes. So we took it to the field. So we set up different, trial with beekeepers. We had different trial. One trial, we have only the control, we don't treat, and then we have a trial with a treatment. We have a treatment where we use those fungal pathogens. So we coat, or we have small traps. So we coat the trap with a fungal pathogen and place them inside the beehive. So we had one strip for about 4 frame of bees, another strip for 4 frame of bees, so all different boxes. And then we record the data over time. So after 42 days, we go ahead and check the data. After 56, 3 months, and 8 months, and 12 months. So over time, we see the progressions of the mite.
What were you looking for as you're checking the data? Are you looking for the death of the mites? Or how healthy the bees are? What sort of things were you looking for?
Yes, at the beginning we have different mite infestations. So about 14 to 18 mite infestations, and then maybe 14 to 12 mite infestation. So we wanted to see if the mite infestation had declined over time. So I'm looking for the death of the bees.
Okay.
So after 42 days, I go and check and see, how many bees still alive and how many mites I can collect. So to do so, we do something we call eToro. So we go there and open the hive, collect the frame, screen down about 300 bees in a jar, and then we do the same thing for each hive, and then bring it back to the lab and count how many. So we can determine how many mites per bees in a control and how many mites per bees in a treatment. So by comparing those, we can see that the mite population decline, between the different treatment. And doing that, using the strips, we're able to control more than 100, probably 98% of the populations. So we start like great. 14, I end up with 2% of populations or 1% of populations. So we know that is effective. Control mite population, and then also the control, maybe 80% of the mites of the bees in the control die compared to 0% in the control.
Now, what did you have on the strips? The mites themselves?
No, on the strip I coat with fungus.
Oh, the fungus.
Yeah,
yes.
Yeah, I coat with fungus.
Okay.
Put the fungus there, so I coat on the strips, and then I place the strip. So for the bees, by trying to get over the strip,
okay.
So they get in touch with fungus, and the fungus drag down to the mite and then kill the mite. There is a small space on the tibia of the mite, a small place on the leg of the mite, where the fungus can grow. It's very humid. Oh. So it grow from there.
So you obtain the fungus from the mites themselves?
Yeah, sometimes, yeah. But when I put the fungus on the strips, so those fungus contaminate the mite. This is one of the techniques that we use to deliver the fungus to the hive.
And that's been very effective.
Very effective.
Wow, that's
now, but it was time consuming a little bit because you got to go. Yeah.
Yes.
So therefore, we got to find a way to make it, less time consuming, less labor intensive.
For the beekeeper.
For a beekeeper.
That's fascinating. Well, we've got to take a quick break right now. And when we come back, we're going to hear some more about your research and how effective it has been. It sounds like it's been very effective, and we'll also share with you how you can find out more information. So we'll be right back with more Land Grant Today.
Give me all your treasure.
Imagine what a little time can do for your family.
Take that.
A message from the Church of Jesus Christ of Latter-day Saints.
Miss me.
Welcome back to Land Grant Today. I'm Cynthia Lamb, and our guest, Dr. Lambert Kanga, has been informing us of so much about honeybees and the uses that they have, as well as the things that they face that are causing their decline. And we were talking about biocontrol methods just before we went to break. Tell us more.
Yes. So a very important way to control honeybees. And we find that honeybees use patties to feed. So therefore, instead of going through the strip that I talked about, so we're trying to make a cake, a patty cakes, where we combine sugar with fungus and also oil shortening. And we put them as a cake, and we put on the top of a hive. And this work very, very well, because the bee will go there and try to feed on a pollen, and then therefore they get into the body. And it's not labor intensive, because just a patty you put on the top and then you continue. So this is the very preferred way that we have developed to be able to control that mite.
Well, how can beekeepers learn more information? We're running out of time, but we want to give our viewers a chance to contact you. How can they reach you to find out more about this exciting biocontrol methods of saving our honeybees?
Yeah, they can find our information on the website of the Center for Biological Control. Also, my phone number is 956-599-8725. But if you do go to the CAFS website and check for the Center of Biological Control, all those information are there. We're currently working with a fungal producing company in Envera to be able to put these biological control agents into the market.
That's
commercial.
Great. So there's hope for the honeybees. And Dr. Kanga, I want to thank you for being with us today, and that's a wrap. We'll see you next time. I'm Cynthia Lamb for Land Grant Today.